The rate at which we're advancing computing is insane. He created a processor for the generative AI era. This is Blackwell.
Is Nvidia becoming the most valuable company in the US?
He thinks it's the most revolutionary. He thinks it's the iPhone.
We saw early on that this way of doing software could change everything.
Microsoft, AWS, Google, Oracle is gearing up for Blackwell.
Oh my God, what are we in for?
In a world where the laws of physics reign supreme, one company has dared to defy them. Nvidia, the titan of technological innovation, has unleashed a game changer, an AI chip that not only breaks boundaries, but exceeds them. This chip is so powerful that it shattered even the most powerful quantum computers. How does this advancement challenge the fundamental principles of physics, and what implications does this hold for the future of artificial intelligence, quantum computers, and beyond? Join us as we unveil Nvidia's breakthrough AI chip that defies physics. Only 4 companies worldwide have reached a market value exceeding $2 trillion. Microsoft, Apple, Alphabet, and the computer chip manufacturer Nvidia. Based in California, Nvidia's market value rose from $1 trillion to $2 trillion in just 8 months. This increase was driven by the high demand for its advanced technology, which supports modern artificial intelligence. It's interesting how a company founded in 1993 to improve video game graphics became a leading AI company in the 21st century. In March 2022, Nvidia introduced the Hopper architecture, designed for data centers to support AI accelerators. The release of Hopper created significant excitement in the AI community, and demand for these products grew rapidly during the AI surge of 2023. Due to shortages and high demand, customers had to wait 36 to 52 weeks for H100-based servers after ordering. In the third quarter of 2023 alone, Nvidia sold about 500,000 Hopper-based H100 accelerators. Nvidia's strong position in the AI market with its Hopper products significantly contributed to the company's market capitalization. Named after the American mathematician David Blackwell, the Blackwell architecture honors his significant contributions to game theory, probability theory, information theory, and statistics. These fields have greatly influenced the design and training algorithms of transformer-based generative AI models. Blackwell was also the first African American scholar inducted into the National Academy of Sciences. During Nvidia's investor presentation in October 2023, the company revealed its updated data center roadmap, now including the B100 and B40 accelerators along with the new Blackwell architecture. Previously, the successor to Hopper was called Hopper Next on the roadmaps. Then, at the Graphics Technology Conference, or GTC, on March 18, 2024, Nvidia officially announced the Blackwell architecture. Over 11,000 attendees, including software developers, tech leaders, and shareholders, gathered at San Jose's Pro Hockey Arena for the 4-day AI event, all eyes on Jensen Huang, Nvidia's CEO. Huang explained that Blackwell was more than just a chip, it's a complete platform. Although typically linked to GPU production, Nvidia expanded beyond traditional designs. Hopper represents the peak of GPU development today, with Blackwell as its foundation. Hopper has 28 billion transistors, but its architecture truly sets it apart. For the first time, Nvidia combined 2 dies into a single chip that communicates at 10 terabytes per second. There are no memory or cache issues, it operates as one large chip. Despite skepticism about Blackwell's ambitious goals, Nvidia pressed on, resulting in the innovative Blackwell chip. Blackwell integrates into 2 types of systems. The first pairs perfectly with Hopper, simplifying upgrades, while the second, shown in a prototype board, highlights its power and future potential. Imagine a setup with 2 Blackwell chips and 4 Blackwell dies connected to a Grace CPU through ultra-fast links. This setup is set to revolutionize computing. According to Huang, this computer is unique, packing immense computing power into a small space. To go even further, Nvidia needed new features to push the limits of physics. Nvidia's latest development is the 5th generation NVLink in the new Transformer engine. This engine, twice as fast as its predecessor Hopper, has computation abilities within the network itself. This is crucial because multiple GPUs need to share and synchronize information quickly. Fast links and the ability to compute within the network greatly enhance performance. Rated at 1.8 terabytes per second, its effective speed exceeds that, making it much faster than Hopper overall. It offers 2.5 times the performance for training per chip thanks to its new FP6 format, and introduces FP4, which doubles throughout for interference tasks. This is important for saving energy, reducing network bandwidth, and optimizing time usage, which will be very beneficial for the future of generative AI. Nvidia calls this era generative AI because it marks a major shift in computing. Nvidia's new processor is designed for this era, with a key feature being content token generation enabled by the FP4 format. This chip, part of the Nvidia Blackwell AI supercomputer, offers 5 times the token generation and interference capability of Hopper. Nvidia aims to surpass this performance by developing an even larger GPU. The NVLink switch is an advanced chip with 50 billion transistors, almost the size of Hopper. It features 4 NVLinks, each operating at 1.8 terabytes per second, allowing every GPU to communicate at full speed simultaneously. This represents a significant advancement in computing. You can build a system based on this technology. This is the latest of the DGX, a major improvement from 6 years ago. The first DGX1 had 170 teraflops, or 0.17 petaflops. Today, Nvidia has achieved 720 petaflops, nearing the exaflop mark for training. This is the world's first exaflop machine in a single rack. Only a few exaflop machines exist globally. This DGX is not just any AI system, it's an exaflop machine in a compact rack. Now, let's explore what makes this possible. The core of the DGX is a NVLink spine, which has an impressive bandwidth of 130 terabytes per second. This exceeds the combined bandwidth of the entire internet. This efficiency is achieved without the need for costly optics or transceivers, saving 20 kilowatts of power. In a rack consuming 120 kilowatts total, every watt saved is important. The DGX is also liquid-cooled, keeping its temperature at 25 degrees Celsius during operation. The cooling system ensures optimal performance with a flow rate of 2 liters per second, maintaining output at 45 degrees Celsius. Now, let's consider the system's GPU. For Nvidia, the GPU is a complex component featuring 600,000 parts and weighing about 3,000 pounds or 1.5 tons. Training a GPT model with 1.8 trillion parameters once took 3 to 5 months with 25,000 amps. Using Hopper, it would require 8,000 GPUs and 15 megawatts of power, finishing in about 90 days. With Blackwell, the same task can be done with 2,000 GPUs and only 4 megawatts of power, showcasing a significant improvement in efficiency and performance. Blackwell is poised to become our most successful product launch yet, and the excitement is tangible as we explore Nvidia's robotics. Nvidia dives into the intriguing realm of physical AI, where machines interact with the real world. Previously, AI has mostly operated in the digital sphere, processing data within a single computer like the DGX system. But imagine a future where AI breaks free from these constraints, where robots possess their own intelligence and navigate real-life environments autonomously. This is where the wonder of robotics ChatGPT moment comes to life. Nvidia has been diligently working on comprehensive systems for robotics, including their AI powerhouse DGX for model training, and AGX, the world's premier robotics processor, designed for efficient sensor processing in low power settings. Bridging the gap between digital and physical realms is Omniverse, Nvidia's virtual world simulation engine hosted in the Azure cloud. It's a bustling warehouse where humans and forklifts work smoothly, overseen by an advanced system acting like an air traffic controller. This smart setup ensures safety by managing traffic and guiding everyone in the warehouse. Surprisingly, you can even chat with this futuristic warehouse. Plus, everything happens instantly. Each robot has its own autonomous stack, making the process smooth and efficient. With Blackwell at the helm, the future of robotics is right around the corner. Let's explore more about these amazing robots. The rise of robotics in various industries seems inevitable due to its safety and convenience. One of the most affected sectors will be the automotive industry. In the coming year, Nvidia will partner with Mercedes and then JLR to integrate their advanced technology. Huang announced that BYD, the world's largest electric vehicle company, will use Nvidia's latest innovation, Thor. This next-generation AV computer, designed for transformer engines, will shape the future of robotics, possibly leading to humanoid robots. In a significant step towards advancing humanoid robotics, Nvidia has introduced Project Groot, an initiative aimed at transforming robot learning. Nvidia is not just imagining, but inventing and exploring to fully realize the potential of humanoid robots. Project Groot is a major advance in robotics, offering a comprehensive foundation model capable of processing multimodal instructions and past interactions. This model, with its sophisticated algorithms, enables humanoid robots to autonomously decide their next actions, effectively linking human commands with robotic execution. At the center of Project Groot is Isaac Lab, a specialized robot learning application created by Nvidia. Using the Omniverse Isaac Sim for simulation, Isaac Lab offers a virtual training ground for humanoid robots to improve their skills and adapt to real-world situations. Alongside Isaac Lab is Osmo, a compute orchestration service that coordinates workflows across Nvidia's DGX and OVX systems, making training and simulation efficient. A standout feature in Project Groot is its ability to learn from minimal human demonstrations. By analyzing just a few human interactions, humanoid robots with Project Groot can assist with everyday tasks and replicate human movements with high accuracy. This is achieved through Nvidia's advanced neural networks, which understand human behavior and translate it into instructions for robots. Project Groot allowed humanoid robots to perform motions based on natural language instructions, improving their flexibility and usability. Whether it's giving high fives or executing complex moves, robots using Project Groot show a high level of intelligence and adaptability. The new Jetson Thor robotics chips, designed by Nvidia, are crucial to Project Groot's capabilities, providing the necessary computational power for optimal performance in humanoid robots. As humanoid robotics advance in autonomy and functionality, Project Groot leads the way in innovation, marking a new era of AI-powered robotics. With Nvidia's strong commitment to excellence in software development and advanced technology, the potential for humanoid robots is vast, promising a future where robots integrate seamlessly into our daily lives, transforming industries and changing how we interact with technology. Now, let's explore how Nvidia became the tech giant it is today. In the 1990s, people experienced fuzzy TV screens, dial-up internet, and beige computer boxes. This decade saw the transformation of personal computers. In the early 90s, displaying a file browser window or blocks of text was the main graphics requirement, and CPUs handled these tasks well unless you were in animation or engineering, which needed more complex graphics. For advanced graphics, video game consoles were the preferred choice. However, three engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, had a different idea. They envisioned a dedicated hardware processor to bring advanced graphics to personal computers. Their brainstorming sessions at a local Denny's, powered by endless coffee, led to an important insight. CPUs were designed for serial processing, handling one task at a time, while generating 3D graphics for games required repetitive, math-intensive tasks that overwhelmed CPUs. Their solution was a separate chip capable of parallel processing, which would be a significant advancement in computing. This chip could divide complex tasks into smaller ones and execute them simultaneously, greatly improving efficiency, especially for rendering 3D graphics. This new chip, later known as a GPU, would work alongside the CPU for graphical tasks. This idea was the starting point for Nvidia and would transform computing and computer science over the next 2 decades. At the time, Nvidia aimed to enhance the gaming experience on PCs, a market with great potential. In 1993, in a condo in Fremont, California, Nvidia's journey began. Nvidia was founded on the innovative idea of integrating parallel processing GPUs into home computers. The name Nvidia combines NV for next version and Nvidia meaning envy in Latin. The green color in their logos represents the envy they wanted to evoke with the powerful computing capabilities of their chips. The founders were highly skilled engineers. Jensen Huang, a Taiwanese-American electrical engineer, brought extensive experience from his roles at LSI Logic and AMD. LSI Logic was important in Nvidia's early days. Jensen Huang co-founded the company with Chris Malachowski, who had engineering experience from HP and Sun Microsystems, and Curtis Preem, a former graphics chip designer at IBM and Sun Microsystems. Although they were skilled engineers, starting a new company came with its own difficulties, which the Nvidia founders quickly realized. In 1993, they faced uncertainty about their next steps. They sought a lawyer's help to incorporate with the company. With only $200, Huang made a significant move by investing his small amount to start Nvidia. This initial investment allowed the company's incorporation and earned Huang a 20% stake in Nvidia. Their next challenge was securing funding to support their ambitious goals. Convincing venture capitalists was difficult. Instead of polished business plans, investors preferred founders with proven success and a strong vision. Despite the challenges, Nvidia eventually caught the attention of Sequoia Capital and Sutter Hill Ventures, securing $20 million in funding. This might seem like a lot for a new company, but Huang's prior connection to LSI Logic was crucial. Using his ties with LSI Logic CEO, Huang arranged a meeting with Sequoia Capital, which had previously invested in LSI Logic. Despite initial doubts, Sequoia Capital decided to invest in Nvidia, seeing potential in the growing graphics card market. They initially invested $2 million, followed by the additional $18 million, setting Nvidia on a path to success. Back then, investing in Nvidia was a risky decision. There were 89 other companies pursuing similar goals, but only AMD and Nvidia survived the competition. When Nvidia went public in 1999, its value reached $600 million, making the initial investment multiply by 100 times. At this point, Nvidia was a small team of engineers. With the funding secured, it took them 2 years to build a team and develop their first product, the NV1. Launched in 1995, the NV1 marked Nvidia's market entry. During its development, Nvidia made a deal with Sega to produce chips for their gaming consoles. These chips were used in popular games like Virtua Fighter and Daytona. The NV1 chips were also compatible with computers, allowing gamers to play Sega Saturn games on their PCs, which was a novel concept in 1995. Nvidia made a bold decision by adopting a quadrangle-based image rendering architecture for their NV1 chips, a move that Sega didn't appreciate. Despite Sega's concerns, Nvidia's leadership remained resolute, refusing to change their direction. But why did they choose quadratics over triangles for rendering polygons? Lazy Game Reviews explains the reasoning behind this decision in a video. Opting for quads or squares instead of triangles aimed to accelerate rendering by reducing the workload on the CPU. The idea was to have fewer polygons, resulting in better rendered curved objects. It allowed for more flexibility in shaping objects with squares rather than being confined to triangles. This approach made sense when CPU speeds and memory capacities were lower, as it enhanced rendering for specific objects or models in games. However, with technology advancements and improved memory capabilities, this approach became less practical over time. Additionally, it raised concerns about compatibility, as there was no support for OpenGL, a widely used graphics API. Nvidia and SGS Thomson even doubted the necessity of OpenGL for consumers. Moreover, when DirectX and Direct3D became available, the NV1's rendering through quads presented further limitations. Nvidia tried to address this with a software patch, enabling the NV1 to run DirectX but only in software mode, nullifying its hardware acceleration capabilities. Despite its innovative intentions, the NV1 project ultimately faltered to make a significant impact. It aimed to offer a versatile solution integrating 3D graphics, video, audio processing, and more into a single chip. However, as Nvidia's CEO Huang later explained, the NV1 resembled an octopus, intricate, multifaceted, and perhaps ahead of its time. Ultimately, it failed to captivate the market's interest. The market desired something simpler, a specialized 3D graphics chip instead of an all-in-one solution like the NV1 chip. Additionally, the NV1 was seen as too expensive compared to its rivals. To compound the issue, the industry was changing, with Microsoft introducing DirectX, a new API that favored a triangle-based standard for 3D graphics rendering. This made graphics coding easier for developers, leading them to adopt DirectX. Unfortunately for Nvidia, the NV1 chip couldn't work with DirectX, causing many existing games to suffer from performance problems or become unplayable on Nvidia's new chip. This incompatibility was a big setback for Nvidia, with their partner Diamond Multimedia returning most of the 250,000 NV1 units they bought due to poor sales and lack of game support. This return nearly bankrupted Nvidia, leading to the layoff of 40 out of 80 employees and leaving them with a surplus of unsellable chips. It was a catastrophic situation, resulting in a $10 million loss. Amid this crisis, Nvidia was developing the NV2 chip for Sega, which also used the same outdated quadrangle architecture. Recognizing the need to change course to survive, Huang made a daring decision. Huang approached Sega's CEO asking to terminate the contract with full payment, which was vital for Nvidia's survival. In a remarkably kind gesture, Sega's CEO granted Huang's respect, enabling Nvidia to realign its focus and resources according to its industry's trends. If Sega had withdrawn their investment at that critical moment, Nvidia would have faced extinction. Nvidia's NV1 experience taught them the importance of understanding customer needs and market trends, shaping their future strategy. It's surprising how close Nvidia came to failure, given its current trillion-dollar value. However, listening to market feedback and focusing on personal computers marked the start of their remarkable success story. After facing a setback, Nvidia decided to make a comeback in the PC industry with a more direct strategy. The timing couldn't have been better, as the PC market was booming. In 1999, Nvidia unveiled the GeForce 256 graphics card, which wasn't just a hit, it revolutionized the industry. Being the first programmable graphics card, it also popularized the term GPU. This breakthrough allowed gamers and developers to explore new creative possibilities with advanced shading and lighting effects, greatly enhancing the gaming experience. Building on this success, Nvidia went public the same year. By 2000, they had clinched a major deal to develop graphics hardware for Microsoft Xbox game console, which provided Nvidia with a significant $200 million advance, marking a substantial leap from their previous console ventures with Sega. The Xbox was introduced in 2001, featuring a specialized chip called the NV2A, crafted by Nvidia. This marked a significant milestone for Nvidia, leading to their success in the 2000s. They played a crucial role in developing processors for Sony's PlayStation 3 and gained the attention of major computer industry players like Apple, Dell, and HP, who integrated Nvidia's GPUs into their products. Nvidia's growth seemed unstoppable due to the strategic decisions and innovative technologies. A pivotal move for Nvidia was positioning itself as a fabless chip company, meaning that they designed chips but outsourced manufacturing. Huang championed this approach to cut costs, partnering with Taiwan Semiconductor Manufacturing Company, or TSMC, a leading semiconductor foundry. TSMC's advanced manufacturing capabilities were crucial to Nvidia's success. While Nvidia focused on chip design, outsourcing manufacturing allowed them to invest in innovation, expanding beyond gaming chips to recognize the potential of GPUs for parallel processing. They aimed to empower developers with tools like Cuda, introduced in 2006, which transformed parallel computing by leveraging GPUs for diverse applications. Before Cuda, programming a GPU was complex and intimidating for developers. It required diving into intricate low-level machine code, or APIs, which often caused headaches. However, Cuda simplified the process by allowing programmers to write GPU-utilizing programs using familiar languages like C, C++, and Java. This innovation had a significant impact, reaching beyond just graphic applications. It enabled various sectors dealing with large datasets to leverage parallel processing power. The momentum picked up in 2008 when the Tokyo Institute of Technology utilized CUDA-accelerated GPUs for their supercomputer, achieving impressive performance. Since then, many data centers, including Amazon Web Services, Google Cloud Platform, and Netflix, have adopted GPUs for diverse applications like cloud computing, machine learning, video streaming, and web search. However, the real game changer occurred with the rise of AI in 2012. A pivotal moment occurred with the introduction of AlexNet, an innovative deep learning neural network. Developed by Alex Krichevsky, a doctoral candidate at the University of Toronto, AlexNet utilized the computational power of GPUs to greatly improve efficiency. By linking two Nvidia GeForce GTX 580 gaming cards to his computer, Krichevsky trained AlexNet's neural network on a vast dataset of 1.2 million images. The outcomes were remarkable. Image recognition accuracy saw a significant boost, reducing the error rate from 25% to 15% compared to the previous year. While these numbers might appear modest today, they represented a major breakthrough at the time, laying the foundation for the advanced AI tools we now rely on, like ChatGPT, Google Gemini, and Google Lens, which offers much higher accuracy. Yet, in the past, this achievement was truly groundbreaking. It signaled the dawn of a new era, dispelling the long-standing doubts surrounding neural networks and sparking what became known as the AI winter. For years, experts had questioned the practicality of neural networks, but the success of this event proved them wrong. The Nvidia GeForce GTX 50 cards played a crucial role in this revolution. Designed for Cuda, they opened the door to parallel algorithms, becoming essential for deep learning tasks like those of AlexNet. This led to a surge in possibilities for deep learning applications, with Nvidia leading the charge. Their investment in Cuda and its ecosystem paid off as Nvidia GPUs became the go-to for training and deploying AI models. OpenAI, known for ChatGPT, relied on Nvidia's A100 series GPUs for rapid deployment. After ChatGPT's successful launch in November 2022, tech giants raced to acquire Nvidia's GPUs, sparking a surge in demand. The A100 GPUs especially were in high demand, with Microsoft purchasing 10,000 units. Despite their high price of $110,000 each, Nvidia sold hundreds of thousands. This unprecedented demand boosted Nvidia's sales to $13.5 billion in the quarter ending July 2023, a 101% increase from the previous year. On May 25th, their stock market value soared to $184 billion in a single day. By May 30th, 2023, Nvidia achieved a historic milestone, reaching a $1 trillion market cap, making it the sixth company globally to do so. Today, Nvidia's market cap exceeds $2 trillion. So share your thoughts on Nvidia's new technology in the comments below. If you enjoyed this video, don't forget to give it a thumbs up.